In this lesson, we'll talk about the sealed keyword. Think of an envelope. Whenever it's sealed, you can't modify its contents, right? And so that's the same idea here. So let's go ahead and create another index card and give you a definition for it. I'm going to actually give you two definitions. The first one is going to be simple. It applies only to classes. So the first definition is when applied to a class, the sealed modifier prevents other classes from inheriting from that class. So if you take a look here on screen, you can see that I have a automobile class, and it has implemented a method called drive. And now suppose I want to create a car class that inherits from automobile. Well, in that situation, everything's fine, but suppose I decide I don't want to allow any other classes to derive from this class. So what I can do is add the sealed keyword, and that will prevent any other classes from saying, hey, I want to be a child of that parent. Notice that we get a red squiggly line underneath car, and it says that cannot derive from sealed type automobile. I'll explain the reasons why we might want to do this in a little bit, because they actually contribute to an important principle of object-oriented programming. So that is the sealed keyword when applied to a class. But we have a second situation here, and let's pick back up our index card and write down the next definition when talking about the properties and methods of a given class. So whenever you apply the sealed keyword to a class member, one that overrides a virtual member of the base class, the sealed keyword prevents derived classes from overriding specific virtual members. All right, so that's a mouthful. But basically, take a look at this example now. We have the class animal with a walk method. We made it virtual. So that means any class that wants to derive from animal can, if they choose to, override that particular implementation. So instead of printing out this animal is walking, for a feline, we print out this feline is prowling. Now, suppose we come along and say, well, that's not specific enough for our purposes. We need to actually create an implementation for a specific type of feline. In this case, I just chose a house cat. And so here I want to override the walk method and say this kitty is pouncing. But suppose that as I'm designing my classes and my inheritance structure, that the walk method is so important that I don't want to allow any other classes from overriding this method, in which case I can add the sealed keyword like so. And when I do that, notice that I get a red squiggly line over the walk method identifier, and it says that it cannot override inherited member feline.walk because it's sealed up. And so again, I want to prevent anything from changing this implementation of the method. Now you can't do that here at the root. If you try to add like sealed up here to this, you'll get an error message on that method itself, and it says it cannot be sealed because it's not an override. So you can't do it at this level. You can only do it whenever you're working with overridden versions of methods, and basically to say, okay, no more. After this, that's it. And so that's basically the two situations that you find the keyword sealed in, and both of them mean the same thing, which means to seal it up so that nobody can change it, but it can be applied to an entire class, or it can be applied to individual members of a class. So I wanted to show you some the sealed C# reference out on MSDN. If you scroll all the way to the bottom, it makes some remarks as to when you would want to consider doing this. And it says, to determine whether to seal a class, method, or property, you should generally consider the following 2 points. The first one is the potential benefits that deriving classes might gain through the ability to customize your class, in which case you don't want to use the sealed keyword. Or, conversely, the potential that deriving classes could modify your classes in such a way that they would no longer work correctly as expected. And so that's the second one is what I want to fixate on. There is a series of patterns and principles called SOLID. I need to create a course about it, but it was first envisioned or dreamed up by Bob Martin, also referred to as Uncle Bob out there in the internet at large. And the L in SOLID, the SOLID is an acronym for like single responsibility principle, open close principle, and the third, the L, is for the Liskov substitution principle. This is probably something we need to talk about later, but that principle states basically that derived types should be suitable for their base types, or suitable substitutions for their base types. In other words, what happens if we have polymorphic behavior that we're expecting by calling various animals in the animal kingdom and calling their walk method. We would expect them to do certain things. We might be so concerned about the implementation of the walk method in, like, dog and wolf and things of that nature, or in this case, house cat, that we say, you know what, we can't take a chance that somebody would implement the walk method incorrectly, so we're going to seal it off from any future implementations. So our concern in that case would be breaking polymorphic behavior, like we learned about in the first or second, I think it was the second video of this course. So in that case, we might want to seal things and make sure nobody else, even ourselves or some other developer, can go forward and try to create a subtype of our animal, or in this case, our feline, or one of its methods. All right. So that's kind of the justification for it. You'd have to get into the thick of software development and a specific project to really see its value. But at a high level, you now have at least, you understand what the sealed keyword is. Hopefully you remember envelope, sealed, can't change it. That's the key point of this video. All right. So we'll continue on in the next video. We'll see you there. Thanks.